Okay.
Okay, so first we're going to start just by talking about some programming concepts and introducing the game engine that we're going to use. Then we're going to develop the game. And after we develop it, we're going to talk about some of the design flaws and how we can fix those issues and what comes next.
Okay, before we start, if you haven't installed Godot or the project files already, I'm going to give you a QR code here. So you can scan this QR code. It's going to take you to a GitHub repository, and you can download the game engine we're going to be using and the project files. If the QR code isn't working, you can use the link at the bottom. So should we wait like, I don't know, 2 minutes for people to get this working?
If you have any issues, I can come around and try to help people.
Okay.
But just to move on, so what is a game engine? Game engines are tools that allow programmers to build games without spending too much time on non-trivial aspects. They're packed with a bunch of tools that are designed to make your job as a programmer easier. You can make a game without a game engine, but you need to cover pretty much everything from scratch, which requires a lot more coding. So just using a game engine makes your life a lot easier. So there are many game engines, but these three are probably the most popular and recognizable. You might have heard about them before, the Unreal and Godot. Unreal Engine is a very graphics-heavy engine that makes AAA graphics obtainable for smaller developers. Unity is a very good engine overall that provides straightforward development processes. And Godot is the most new among the three. It provides a similar process to Unity, but is lighter with less graphical options. All three of them are very good game engines, and you can use any of them, have great results. There's just a few differences between why you choose one. So for this workshop, we chose Godot. We want everyone to be able to participate in this workshop and make it easy to get into it, which is why we chose Godot. It's a much smaller size and can run on pretty much any system with not a lot of high system requirements. Godot also has visual scripting, which is what we use to program the game just to make it a little bit easier. So visual scripting is a graphical interface provided by the game engine, in this case Godot. It allows people to program games without actually having to type code. It works just by connecting nodes together to form a map of functions that the program runs through. So we only have to just connect the nodes and design what we want the game to do instead of having to write the code itself, which makes it a lot easier for this beginning workshop.
Okay, so that was it for the first half of the presentation of the workshop. From now on, I'm going to share my screen. I'm going to share Godot, the game, and then we're going to start developing it. So I'm going to first show you the final version of the game. All right, so should be able to see that.
Yeah, we can.
Okay, can you see the game?
Yeah.
All right, nice. So this is what we're going to be making today. We're going to be programming the movement of the spaceship so we can turn around. It's going forward by itself. We're not controlling that. And as time passes, the spaceship gets faster. So that's a bit of challenge for the player. At the top left, you can see the survival time. So we're letting know the player how much time they've survived. And that's the goal of the game, to survive as much as you can. So we're going to be coding the movement of the spaceship. We're going to be coding the procedural spawning of the planets. And then we're going to be coding the UI for the survival time. So I'm going to switch to my template project. Okay, can you see this?
Yeah.
Okay.
Always.
All right, and is everyone ready?
Anyone have any issues? Seems like we're ready.
All good? Oh, sorry, I couldn't hear you, Colin.
Yeah, we are good, sorry.
Okay. Okay, so this is the project view. We have the big canvas in the middle. That's the scene view. That's what the player is going to be seeing. And then we have our scene root, which is a hierarchical view of every single object in the scene. So for example, we have our spaceship, we have our planet spawner, we've got our UI here. So everything that's in the scene, we can see from there. At the bottom left, we have our file system. So this is all of our game assets in one place. I put them in different folders. So all of our scenes or levels are in the scene folder. All of our scripts are in the scripts folder. And then we got our texture. And then that's pretty much what we need. There's also the inspector. We're going to be using that in a minute. So keep that in mind. So to get started, we're going to head to the script tab at the top. So we have 2D, 3D, and then script. Click on that. You should have a blank screen like this. So we need to open a script. I already created the scripts. They're just empty. So we're just going to click on the spaceship script at the bottom in your file system. So that's script_spaceship. And here we're going to program our spaceship's movement. All right, so before we actually start programming, we need to understand what we're actually doing. So the spaceship is going to be moving continuously forward. We're not going to be able to stop. So we need a speed for that. So I can add a variable that's going to define my speed. I'm going to call it speed. And of course, you can create variables from the plus sign here next to variables. And then the type of speed, so it's going to be a numerical value. It's going to be a float. I'm going to right click on my variable. I'm going to say edit member. And it's going to pop up this little window where I can select the type of variable this is. So it can be a true or false value. It can be an integer, a whole number. For this, we're going to be using a float, which is basically a decimal number. And we can set the default value. I'm going to set mine to like 200. And before I close, I'm going to export this. So what that does is, if we go back into our scene, if I click on my spaceship, now I can see the variable through the inspector once I click on the spaceship, and I can edit this variable for this instance. So the spaceship in the scene is going to have speed of 100, or I can change it to 500, 200, whatever I want. This is really good if you're debugging, or if you have lots of different spaceships that you want to control that have different speeds. So it's a very easy way to adjust the speed or the variables of that particular instance. So we have our speed, our spaceship's going to be moving forward, but we also want it to keep accelerating. So I'm going to make another variable for that. I'm going to call it acceleration. And this is also going to be a float value. The value can be pretty small because we don't want spaceship to accelerate very quickly. So 20 is okay. I'm going to export that. Now our spaceship's moving forward. It's accelerating over time. And lastly, we also need the rotation. So the player is going to be able to control the spaceship's rotation. That's going to be the right and the left key, the arrow keys. So I'm going to make another variable to define my rotation speed. And it's going to be a float, and I'm going to export it. It's going to be pretty small, something like 5 maybe. We can edit this later on if it's too low or too high. But for now, let's do 5. So These are all the variables we need to make the spaceship move. Now we need to write some functions. So at the top of variables, we have functions, and we can make a new function here. As you can see, it's going to pop up our function where we can add functions and nodes to let that function actually do stuff. And before we do that, I'm going to rename my function to move forward. So this function is going to be responsible of moving forward the spaceship. And let's make another function. Let's call this rotate ship. So, and this function is going to take in the player input, and it's going to rotate the ship based on that input. We need one more function. That's going to be the increase speed. And this function is going to take in our acceleration value, and it's going to add that value every frame to the ship's speed. So the ship accelerates continuously. Okay, so we have our functions, they're all empty. We're going to start with the move forward function. Let me know if I'm going too fast. I tend to do that, so I can slow down if you want.
He asked if you can zoom in a little bit. It is hard to see.
Yeah.
I need to zoom in.
Yeah,
Yeah.
like, is that good?
He means like, I think the stuff on the left side.
Okay, let me restart this so I can scale up my editor. Okay, is this better?
Is that better for the Zoom?
You can zoom it a bit more in if you need to. Okay, that should be pretty good, yeah.
Can everyone see it now? Is that good?
Sorry, I couldn't hear you.
Yeah, it's good.
Okay, all right, nice. Yeah, so if you haven't seen what I did, so at the bottom left here, I used the plus sign here to create new functions, and I just renamed them to these functions here: increase speed, move forward, and rotate ship. I declared some variables with this plus sign again, and I renamed them, and then I set their type to float. I set their values, and then I exported them all. And these are my functions at the bottom here. Sorry, variables. Okay, I'm going to continue on with the move forward function. We're going to make the spaceship move forward. And this is going to be without the player input. So the spaceship's going to keep moving forward by itself. So to do that, let me just pull up my cheat sheet. Okay, so to do that, we can use a function called, so I right click on my canvas and I type in move and collide. This function is going to make the spaceship move to whichever direction we specify. And then if there's a collision, it's going to return the object we collided with. I'm going to connect those, and that's pretty much it for the function. But of course, we need to specify the direction of the spaceship and the speed. So I'm going to bring in my speed variable. I'm going to get my global transform. So write get underscore global transform and get that function. And this function is going to return the rotation, the transform of the spaceship. And we're going to deconstruct this transform which is going to give us the X direction, the Y direction, and the origin or the position of the spaceship. So here the transform is just a struct that holds these components. And once we deconstruct it, we're just going to use the Y value because that's the forward direction. So we can just plug this in like that and it should work, but that would make the spaceship move forward with, I'm sorry?
Can you wait just a second?
Which deconstruct transform 2D, because there's like 10 of them.
What? Oh, there's multiple deconstructions.
When I searched deconstruct transform 2D and there's like 10 of them.
Okay,
You have one
so
with the matching
once you're in
symbols?
your spaceship script and you type get global transform,
I have,
there
yeah,
you can first, before you right click on the canvas, you can drag the output node here that says T2D, and you can drag it and drop it, and it's going to create that list where you can type in deconstruct, and it's going to give you the only deconstruct that's available for that node.
Is that-
I think so.
Did that work?
We'll see.
Did it give you the one?
I mean, it gave me a lot of them, but
Oh.
I just picked one and it can fit, so.
Yeah, so
I
if
guess
you're
let's
getting
see, I
the
don't-
X, Y, and origin values, I think it should be fine.
It's got that, so.
Okay.
All good?
Yeah.
All right. All right, so well, we deconstructed our transform to get the forward direction. We can plug this into our move and collide function, but that's only going to move the spaceship forward 1 unit at a time per frame. So we need to get our speed variable, and we're going to connect that or multiply that with the direction to get a velocity. And before I do that, I want to click on my move forward function here. And in the inspector view, I'm going to increase my argument count. I'm going to make it 1. And it's going to create this little dropdown called argument 1. I'm going to change the name of that to delta, and the type is going to be a float. Now, delta is the time between each frame. So if you're having like 60 frames, that's like 0.0 something seconds between each frame, and that's the delta. We need that because imagine your game is running at 60 FPS and you're moving the spaceship 5 units at a time every frame. You're going at a speed, and then imagine somebody who's playing the game at 144 hertz or 144 FPS. That person is also moving the spaceship forward at the same speed, but 144 times per second compared to your 60. So we basically need to normalize the speed so that it is the same speed across all hardware and all frames per second. So I'm just going to, again, drag my delta, drop it, and then type in multiply. And it's going to be math multiply. I'm going to connect my delta to that node. And here, the resulting value at the end is going to be delta times value. Now I'm going to multiply this 1 more time. Because Godot is a bit weird and forward direction in Godot is -y and not y, so I need to multiply this by -1 to revert the direction so the spaceship's going forward rather than backwards. And here we have our forward direction, we have our speed, we just multiply them. So if I type in multiply after I drag and drop my y direction, this is what I get. Now you're going to see it's not compatible because one's a float and one's a vector 2. So we need to construct vector 2. And there's going to be a ton of stuff here. You're going to have to find vector 2 from this. It should be called construct vector 2 xy. So this one right here. And that's going to make us a node that takes in 2 float values and gives us back a vector 2. I'm going to connect my speed to the x and y. And now I can multiply it. So there we go. That's our velocity. So I connected that to my move and collide function. And now the spaceship is going to move forward. It's not, because we haven't connected our move forward function to anything yet. So it's not going to be called, and the spaceship's not going to be moving forward. But once we do call this, the spaceship's going to move forward every frame. Right, so now we can move on to the rotate ship function. Here, you don't need to have delta, you can. It's not really too big of a deal, but I'm just gonna include delta the same way I did in the first function. Okay, so here we're going to take in player input. And to do that, I'm gonna right click and then I'm gonna type action, which is going to give me the actions the player can do or the buttons they can press. And this function returns me a Boolean, a true or false value, which I can plug into an if statement or a condition in Godot, which I can call different paths in the visual scripting to do different stuff. So I can rotate left or right based on the input. Okay, so I click on action. In the inspector, I can select which action it checks for. So we're looking for UI right. And I'm going to make another action node here. And I'm going to click on it. This is going to be UI left. So that's the right and left arrow keys. Right. So we're working with UI right now. I'm going to right click. I'm going to say condition. This is an if statement. If you don't know what it is, it takes in a true or false value, which is this one right here, like this. And then it returns true or false based on that value. So we can go to take different paths based on if the player is pressing the button or not. All right. When you right click, you can just type in rotate. That's going to bring up a function that's going to rotate the ship, the transform of the ship. So we're going to, once we press the right button, if it's true, we're going to call rotate. It's going to rotate the spaceship by rotation speed. So I just drag and drop my rotation speed. I connect that to my function. And now when the player presses the right key button, the spaceship's going to rotate clockwise. And now we need to check if the player is pressing the left button. So I'm going to make another condition. And I'm going to connect my UI left to the Boolean or the true false value. And here we need to connect the false path of the first condition to the second condition. So it's going to check if we're pressing the right button. If we are, it's going to rotate it clockwise. If we're not pressing it, it's going to check if we're pressing the left button instead. And if we are, we're going to rotate the ship again. Just right click on the canvas. We're going to rotate the ship. But this time, we're going to get rotation speed, and we're going to multiply it by -1. So we rotate the opposite direction. Okay. Yep, so that should be it for this function. We didn't multiply it by delta though. So we can do that. How we're gonna do that is we're gonna take in our rotation speed, call multiply the two values and then plug them in. We can delete these now. I can delete this one, and plug the same value. So you can use the same return value twice or multiple times. Okay, so now I have my rotation speed multiplied by my delta, so it's going to be smooth across all hardware. my rotation speed gets multiplied by -1. So when I'm pressing left, it's going to rotate counterclockwise. And that is it for this function. I'm moving on to the increase speed function. This function is going to increase the spaceship speed by acceleration every frame. So we need the delta again, float delta. I'm going to drag and drop my acceleration, and I'm going to multiply them. So again, the acceleration is going to be working correctly on all hardware. So how are we going to do this? We want to, so if we go back into our move forward, we want the spaceship to accelerate. And the spaceship is going forward with the speed variable. So we want to change the value of the speed variable to affect the speed of the ship. So I'm going to drag my speed, and before I drop it, I'm going to hold control. And when I do that, it's going to give me a node that lets me set the speed or set the value of the variable. I'm just going to connect those. And we can't just do this, because once we do that, we're just setting the speed to the acceleration. We want to increase the speed. It's going to be additive. So I'm going to get my speed, and I'm going to do add. And I'm going to add my acceleration to my speed, and I'm going to set it again. So if we have 200 speed and we accelerate by 20, that's going to be 220 speed at that frame. And then it's going to keep increasing 240, 260, and so on. Okay, so we programmed our spaceship, but if I start the game, it's not going to work because we're not calling any of the functions. Godot comes with a built-in function at the bottom left, next to the plus sign on the functions section. There's this little box with a down arrow. You can click on that, and it's going to give you a list of built-in functions that you can use. We're going to be using physics process. So this function gets called every frame, and we can set what this function does. So it's an empty function. You can add functions into it, and the functions that you add into it are going to be called every single frame. So I'm going to add this. Okay, it's right here. It can be a bit hard to find. Yeah, Godot has some issues with this visual scripting tool, but it works. So find the physics process function, bring it up here, and we're going to call our functions. So increase speed, move forward, and rotate ship. We can simply just connect these. It doesn't matter which order. And then once they're connected, we need to connect the delta value as well. So the physics process, it runs every frame, and it returns the time between the frames. So the delta value, I'm going to connect those, and let's see if our spaceship is moving. Okay, so this is what I got. My spaceship is moving. I can rotate my spaceship. It's not going backwards, so we multiplied by -1. If we didn't do that, our spaceship would be going backwards. A little quirk of Godot. So yeah, we finished the first part of the development of the work of the game. We have our spaceship. It's working all right, looking good. The speed is also, I think, pretty good. The rotation speed, the speed itself, it's definitely accelerating. So everything seems to be working fine, and we can move on. Okay, so I'm in the spaceship script. I'm going to go back into my scripts folder, and I'm going to click on my spawner script.
Can I ask him to go back to the spaceship script and like zoom in on the functions?
Yeah.
See how they're connected?
That even particularly you wanted me to see you just.
The rotation speed. Okay.
Yeah.
Are we good to move on? If you have any questions, I can answer them.
What?
Will this be uploaded?
The finished thing will be uploaded, yeah.
Wait.
Colin, is there a problem?
No, I think we're good now.
Okay. All right. If everyone is done with the spaceship script, if nobody has any problems that I can answer, I'm going to move on to my spawner script. So in this script, we're just going to spawn planets in random positions. I already have my planets ready. So, oops. If I go into my scenes folder, you're going to see we have the planet scene. You can double click on this. And in our 2D scene, there's going to be a single planet here. So we're going to take the scene and we're going to instantiate it. We're going to spawn a bunch of these scenes around our main scene, which is the space scene at the top here. And everything in the planet scene is already finished. So we have a collision, we have a sprite that's randomized, and the size is also randomized. So we only need to spawn it in random positions. And we're going to do that inside the spawner script. Right, so again, we're going to make some variables. I'm going to call my first variable the target planet count. So this is going to hold how many planets we want to spawn. Depending on your PC, you can spawn a small amount of planets or a large amount of planets. It might take some time, so don't go too crazy with it. I'm going to spawn 1,000 planets. I'm going to export this so I can edit it inside the scene quickly without going into my script. And then to keep track of how many planets we spawned so far, I'm going to make a current planet count variable. And these aren't floats, these are integers because we can't spawn half a planet. It's going to be 0. We don't need to export this. And I'm going to close that. We need a single function to spawn planets. It's going to be called spawn planets. And we're going to use a while loop. So right click on the canvas and then type in while. What this does is it takes a Boolean, and until that Boolean is false, it keeps repeating every frame. So once our spawn planets function gets called, it checks if the Boolean is true, and then it fires this path called repeat. And once that path is done, it checks again, is the Boolean value true or false? If it's true, it fires it again. If it's false, it stops. So I'm just going to connect my while loop to my function. And here I'm going to drag and drop my target and my current planet count. So what we're going to do is we're going to spawn a planet on every time the while loop repeats. And once we spawn a planet, we're going to increase the number of our current planet count variable by 1. And so we can compare the current planet count to the target planet count. So if the current planet count is equal or greater than the target planet count, we want to stop spawning planets. So we can check that by dragging the current planet count and then typing compare less. So compare less or equal. And I can connect my target planet count. It's going to check if my current planet count is smaller than or equal to my target planet count. And if it is, it's going to return true. If it's not, it's going to return false. Okay, so now we can just spawn the planets. There's a function called instantiate. It's not here because we need to go into our file system, and inside the scenes folder, we need to drag and drop our planet scene into the script. And that's going to create this node called preload. It's just the path to that scene. And we're going to use that this object here that it returns to instantiate the planets. So we drag the object, we drop it, and then we type in instance. So it's the function right here. And we're going to instantiate the planets every time the while loop repeats. Okay. So what this function does is it takes in the thing you want to spawn. It creates an instance of it. So it spawns it, and then it returns a reference to that object that you spawned. So at this point, we have our planets spawning, but they're all at 0, 0, 0 position-wise. We want to randomize them, and the class that has the positional values is called a static body 2D. And because the return value here is ambiguous, we don't know what it is, we need to use a typecast. So I'm going to drag and drop this, and I'm going to type typecast. This function here, or this node, takes in the value, and then it checks if that value is of a specific type. If it is, you can call the yes path. If it's not, it calls the no path. So right now it's an empty function. You click on it, and then at the inspector window, we can set the base type to a static body 2D. So at the bottom here, static body 2D, it's like a purple square icon. I'm going to click that, and now our typecast is checking if the object that's returned from the instance function is a static body 2D or not. And at this point, we're going to create a random vector 2, so a random position. And that random position is going to be inside a spawning range. So we don't want to spawn planets somewhere the player is never going to reach. So it has to be contained in a square or a circle or whatever. So I'm going to make a new variable. I'm going to call this spawning range. I'm going to make it a float. Default value can be like 5,000. I can export this. And with this function, what we're going to do is we're going to spawn the functions on both x and y, spawn the planets on both x and y from -5,000 to 5,000. So I'm going to set position, and as you can see, there is no set position function. So that's where the typecast comes in. I'm going to drag my object here, and this object knows it's a static body 2D because it's returned from a typecast. It has a specific type. So there, as you can see, we have a static body 2D here. Now I can set position. So when I call this function, it's just going to set the position of the planets. So right now it's 0, 0. So it's going to spawn it at the center of the scene. We want to make a random location that takes in the value of spawning range. So we wanted to make it from -5,000 to 5,000. So I'm going to drag this and create a multiply node here. And I'm going to multiply it by -1. So we have -500. We can still access this to get 5,000. Sorry, I keep saying 500, 5,000. So calling this and multiplying this doesn't actually set the value of spawning range. It just creates a new instance, basically, that has a negated value. So there's a function called random. And once you click on it, it makes a node called rand_range. It's not the same name as in the list, but it is what it is. So rand range. We're going to plug in our negative value, and we're going to plug in our positive value. So this is going to return us a value from -5,000 to 5,000. I'm going to click on it and then hold Control and press D. So that's duplicating the node, Control D. And I'm going to make a second one here. So one of them is going to be our X and the other one is going to be our Y value in the position. So just like in the previous script in the spaceship, we had to construct a vector too because we can't convert float to a vector to straight away. So construct vector 2. I scroll down and then here highlighted, it says construct vector 2 XY. I'm going to click on that. I'm going to plug in my X and Y values. And I'm going to plug in my return value to my set position. So what this is going to do is it takes in the spawning range. It negates it. So we have -5,000. It enters this function. So this function generates random value between -5,000 and 5,000. And we plug these two into our construct vector 2, and we have a random position. But for this to work, we need to right click and then call randomize. If we don't do this, every time the player starts the game, it's going to return the same random value, which is not random. So we need to call this to randomize the random values, which is a bit stupid. Why would I use random range if it's not going to return me random values? But whatever. So yeah, we spawn the planets, we randomize our script, and then we set the position. And before we forget this, we need to increment the current planet count every time we spawn a planet. So at the end here, I'm going to call my current planet count. I'm going to hold Control, drop it, and I'm going to connect this. And we want to increment it by 1. So I'm going to get my planet count. I'm going to add 1. And then I'm going to connect this. So it's going to increment it every time we spawn a planet. And once it's large enough, once it's equal or greater than the target planet count, it's going to stop. Okay. So again, from the functions.
What function he used to increment the current planet count?
So there isn't a built-in increment function. So you need to use add, and you need to add 1. So is that okay?
Okay, yeah, that's good.
Sorry. Okay. So from the functions section, again, we're going to create a built-in function. and this is going to be called ready. So unlike the physics process function we called on the other script, this function only runs once when the script starts or when the scene starts. And it only runs once. It doesn't run continuously every frame. And that's exactly what we want. We want to run this, run our function spawn planets once when we start the level, and then we want to be finished with it. So I'm going to drag and drop my planet or my spawn planets function, and I'm going to test if this is working. So I don't see anything. This doesn't mean it's not working. It might mean that it's just maybe our spawning range is too huge and we spawn too little planets, so it's hard to come across planets. So to debug this a bit easier, what I'm going to do is I'm going to go into my space scene. So this is my space scene. I'm going to click on my spaceship, and sorry, so it's a hierarchical view. Under my spaceship, there's a camera 2D. I'm going to click on my camera, and then I'm going to set the zoom values to something higher. So something crazy like 50. So that's going to zoom out our camera, and it's going to show much more of the scene. All right, so the tiny little thing in the middle is the spaceship. We still don't see any planets, so I guess something is wrong with the script. That's completely fine. We can just go into our script and see what's happening. So everything seems fine actually. Does anybody have any comments? Did you see anything wrong that I should fix, or? Huh. Maybe. Okay, how about this?
Like we can sense like.
Okay, there we go. Let me share my screen now. Okay, so our planets are spawning. It's jittering a bit because our spaceship is colliding with under all of these planets. Terrible game design. So we need to either increase the spawning range, or we need to decrease the amount of planets we spawn. So I'm going to close this. I'm going to go back into my project. So so this is where our export of variables come in handy. I go into my spaceship, and the spawner object at the left under the scene root, that's what's calling the planet spawner script. So at the bottom here, the script that's attached is the script that we just programmed. And here, the variables that we exported are showing. So I can just set this to something much bigger, 20,000. Let me just check if this is looking good. Okay. All right, so as you can see, this is much better. It's a little hard to see the spaceship, but the planets are looking good, so they're all randomized. And so clearly this is a cube, it's a square. So the planets like cut off at the top right there. At the left and right, we see planets not spawning. So that's our spawning range. We can make this higher if we want a larger playing space. Let's stick with this for now, and let's move on. So how is everybody doing right now? Were you able to get the planet spawning? Colin, how is everything looking?
Everyone. I think so.
Okay.
We are running out of time, so I think we should.
Oh yeah, yeah. Yeah, so it's past 12. I didn't even realize that.
Yeah.
The final script, the final project with all the scripts are going to be in the repository. I'm going to upload this video as well, either on GitHub or on YouTube. So you can, if you want to continue on the project, you can do it there. So right now, what we have is a moving spaceship that you can control left or right. And then we have our planet spawning script. So what's left for you to do is inside the spaceship script. So we go back to the spaceship script. You need to actually detect the collisions and do something about it. And I can share the slides as well. The slides have instructions for you to follow to get everything working. If you do exactly what the slides are showing, everything should be okay. So this is where I stop. I'm going to go back into our slides, and I'm going to let Colin continue. Let me make this larger. Okay.
Okay, just because we're running out of time. So we didn't really get completely done just because it took us a bit to set it up. But we can still talk about just some of the design problems that we had. So even with the finished product, the player can just sit there and keep spinning in circles, which completely just breaks the game. The player just keeps moving and the speed increasing doesn't matter. So that's just a small issue, but you can just have a way to make sure that the planets move or things like that. There's also an issue that because the spaceship speed just keeps increasing, eventually you will just lose just because you can't control it anymore. And you can fix that by having just a variable that updates over time with the speed. There was also some issues with generation in the end, where that player can escape the spawning range. That's kind of an issue with the computer resources, where how large can you make the spawning range? You could just keep making it larger, but at a certain point it gets so resource heavy. And the final issue was just that sometimes you just start the game and it spawns right on top of you and you instantly lose. That's a more simple fix. You just have to restrict the range of the planet spawning. But these were just some of the design problems we wanted to talk about. Unfortunately, we ran out of time to discuss them in detail, but so
yeah, we can just finish. This is going to be pretty quick anyways, so
yeah. But just to wrap it up, it's just really what comes next. We started making a really simple game, and if you want, you can take it. We'll upload the finished product. You can add your own exciting and fun twist. You can add some fun sound effects, visual effects, those type of things. Game design is not always about being perfect. It's just about enjoying yourself and making a fun product. So I hope that even though we didn't finish it, y'all enjoyed the little bit that we got through.
Nope. Thank you.